Hi, everyone, and welcome to the Semgrep 101 webinar. I am Tanya Janca. I'm your host. I work in community and education for Semgrep, and I want to thank all of you for coming today. So as people are joining, I'm just going to give you all some time so that, everyone can get in and we're not starting and you don't know what's going on. But I was thinking I'd start with sharing my slides. Oh, wait just a second. How am I going to do this? Presenter view. Yes. Okay, perfect. So I'm going to share my slides so that all of you can see them. Can anyone confirm for me that you can see my slides and that they're looking okay and everything's clear? Oh, hi, Jennifer. Awesome. Thank you so much. Okay, so not to repeat myself, but since people are still joining, so welcome to the Semgrep 101 webinar. And today I want to just give you kind of like an overview of what the heck is Semgrep? What is Tanya talking about? It's going to be more of like a technical overview of what things do, and then there'll be a demo at the end. And the idea isn't to sell it to you. The idea is to explain it to you so you understand what it is, why you might want to use each part and when, and just so that you know that these types of tools exist. So Semgrep makes 3 types of tools, and we're going to go over each one, but there's lots of companies that make different types of these tools. So you knowing that they exist, when you might want to use one, why, how, and like the value that they offer, I personally find pretty helpful. And so with that, it's 3 minutes after, and I was thinking I would start, and basically we'll go from there. Okay, so hi, welcome to Semgrep 101. I know I already said that. I'm Tanya Janca, your host, and I wanted to talk to you about what we do. So this presentation become awesome in only 45 minutes. Yes. So what are we going to talk about today? So we're going to talk about what is static analysis, and basically when you would want to do it. Well, actually, introduction. So what is static application security testing or static analysis? Tips for rolling out a tool, and like how to get the best value, how to choose the tool that's actually best for you, and how to like roll it out, like things you can do with it so that you get more and more value, because you don't want to only get value the first month. Then we're going to talk about supply chain and supply chain security. So what is software composition analysis? What is a supply chain? How to get the best value out of one of these tools. And then we'll talk about something called Reachability, which is a thing I think that Semgrep started, and it's pretty nifty. And then we're going to talk about secrets. So what the heck are secrets, and why should we really not store them in our code? We're going to talk about how to find them, how to rotate them, and validation of secrets. So it's nice you found a secret in your code. Like, is it a real secret, or is it an old secret that no one's using anymore? So I personally find that helpful to know. So a small amount of help of housekeeping. You can ask questions in the chat, or you can ask questions in the Q&A. You can ask a question whenever you want. I'd rather you have an answer given to you that's helpful than like have some perfect smooth presentation, if that makes sense. Because if I didn't explain something enough, you probably have a question. So I'd rather answer it as we go. So please don't feel bad to ask a question. Oh, putting stickers on things, 5-year-olds and IT professionals. Oh, wait, this is the wrong meme. This is the meme I was supposed to do. The future of software development. Yes, that's what I was supposed to say. It's not supposed to say putting stickers on things, but it's true. I put a lot of stickers on things. Okay, so with that, what is static application security testing? Also known as static analysis. So basically, a SAST, or a static analysis tool, is a piece of software, and you scan your software with it, and it tries to find security bugs. That's all it does. It tries to find potential security problems, implementations, like the way you wrote the code, there's some sort of security problem. So it might be that you used a function that has problems in it and it's not very secure. It could be that you missed a step in secure coding. So you got some input from the user, then you didn't validate it, and then you used it somewhere and it's like, that's pretty dangerous. What if that input from the user was not very nice? And so it tries to find bugs for you. It's called static because it's run against the written code. It's not run against a running application. So dynamic application security testing, or DAST, same with a pen test or a stress test or a performance test, all of those are against running applications. You need the application to be like on a web server, a container, a platform as a service for them to work. This, you don't need that. That means your code doesn't even have to be compilable yet, and you can run one of these. There are a couple on the market where you have to have compiled the code down into a binary for it to work, but Semgrep's not one of them. It can work. You could just hook it up to your code repository or send it a file of code you wrote and it'll check it for you. And so that's what it means by stack analysis. It's unchanging. Dynamic is when it's running, it's literally changing before your very eyes. So it's a different way of looking at your app. So why would we do stack analysis? Like, what value does that bring? Well, we can use a stack analysis tool, or a SAST, to enforce important guardrails. So we can say, if you're going to get input from the user, you have to validate that it's what you're expecting before you use it in your app, or before you send it to a database, or before you turn it into a request. So you can do that by making these guardrails, these rules that run against your code. It prevents bugs that have occurred before. So if you find a bug, you can make a rule for it, and then make sure that from then on you find that bug again. These tools come with tons of rules written by experts. At Semgrep, we have this giant team that does it. And like there's a lot of people on the security research team. There's a lot. We got to play mini putt with them this summer, which was really fun. I'm not good at mini putt, but anyway, so they try to find bugs that have occurred before. You can use them to try to eliminate an entire class of bugs. So let's say you don't like injection. I don't like injection. It's a very bad type of bug. You could use it to scan across your whole code base, find all of them and fix all of them. So you can test over and over again with one of these tools because it's automated. So you can fix a bug and then run it to see if you fixed it properly. It helps you scale your team. So if you wanted to hire, well, first of all, I don't like to do manual code review all day long. That sounds terrible. I would not say yes if I got offered that job. But so someone who is willing to do code review all day long, there's not that many of them. There's certainly not enough of them to review every line of code for every app. There just isn't. And so when we use these automated tools, it helps us scale our security programs, because you can scan every single app in not very long period of time, whereas a human being might take a year to do that. You could probably do that in a few hours. With some SAST are slower than others. Some of them might take a few weeks, but still both types are much, much faster than a human being. And so it helps you scale your AppSec program. It also means you don't have to hire a super duper expert. So I can run one of these super easily. I've been running it all morning, playing with it for my demo, because that's what I'm like. And I was like deleting projects and adding projects and fooling around. And I didn't have to actually review any code. I just pressed buttons and set up some CIs. I was like, boop, boop, beep, beep. And then it just started giving me answers and telling me what it found. And so you don't have to hire an expert to run this. And that's part of the greatness too, because it's hard to hire AppSec folks. It really is. Okay, so what is a first generation SAST? So this is a thing that I've come up with. And then more and more AppSec professionals, we talk about it, and I'm trying to get the same language going with everyone. So I like to call certain static analysis tools first generation SAST, and then other ones second gen. And the reason for this is that basically once COVID happened, a bunch of new companies came out with a new way of doing static analysis. And the way they do it is different and the results are different. And so I started figuring out like these ones are good for this and those ones are good for that. And they still both try to find bugs in your written code. But because the results are so different and the way they work is so different, I feel it's important to differentiate because then you know which one you need depending upon what you're doing. And so first generation SAST tools, actually, let me just see, just a second. Okay, so first generation SAST tools, they do symbolic execution. And what that means is they go through every single potential outcome of your code, every single avenue that it could go, including many levels of recursion. And this takes a long time. And then it parses all of that down, breaks it into pieces, just like a compiler would. I had to write a compiler back in college. Yeah, that sucked. It was hard. And it does all of that to try to find every single potential bug. It is extremely slow. And it goes through lots of code that would never, ever run in production. So it takes hours, sometimes days to run. So the first time I did this, so I hired a guy to come in. And I remember it took him a few hours to get it set up and turned on. And then he's like, great, it's scanning. I'm like, excellent. He's like, okay. And he kind of like stared at it for a few minutes. He's like, okay, it's good, it's running. And then he goes to put his jacket on. And I was like, oh, maybe he's going to go get a coffee because it's going to take so long. He has time to go downstairs and get a coffee. And then I'm like, but he's got a jacket. So maybe he's going to go across the street to the fancy coffee place. I'm like, how much time does he think he has? I'm like, oh, you're going to go get a coffee? And he's like, oh, I'm going home. I'm like, what do you mean you're going home? He's like, oh, this won't finish till tomorrow or the next day. He's like, I think Thursday. I'm like, what? No, like we would like the results like when they're ready. And he's like, yeah, like it'll finish running like then. No, but it's Monday, buddy. So he came back the next day and it had crashed. We had to get him a more powerful computer. The computer could not do anything else. So he ran from Tuesday to Thursday. Then we get the results. I'm like, great, can I see them? He's like, you can if you want, but they're useless. I'm going to need to dig through them for a few weeks and figure out what's actually wrong. And then I'll give you a report. It took 3 weeks. It was $10,000 for the license for this tool. Then we had to pay him $30,000 for his time. And it took 3 weeks of full-time work for it to finish. That is like $40,000 plus time. And then we got 20 bugs. 20 bugs. That is a lot of money per bug. It was intense. It needed a separate beefy server to run. So like I couldn't run it on my dev machine. I tried to, and it just exploded a bunch of times. We couldn't show the results directly to the devs because it was just almost, it was like 200 pages, the report, but there are only 20 real problems in there. The rest were just false positives. It was also like, we couldn't run, there's no way we could have run it in our CI/CD. There's no way we could have attached it to our code repository. Like this was years ago. This was 2014, or no, it was 2015. It was early 2015. It was winter 2015. So it was a while ago. It was 8 years ago, but it wouldn't work with our build server or anything. It was closed source. So it's not like we could have added rules or things to it if we wanted to. But it found lots of stuff. So it found 22 memory leaks, which was really important to us because we had to run our product in the Arctic because I live in Canada. And so that was a thing. And that was important to us. But it found good stuff and bad stuff. Okay, so what is next gen or second generation SAST? So big data. Oh, no, Tanya, not that type of next generation. Let me explain. I'll try again. So next generation static analysis, it finds bugs not with symbolic execution. Instead, it does, so both do flow analysis. So flow analysis is fast. Flow analysis is basically a source. So I get some input from somewhere. So it could be from the user, from an API call, from the database. So that's my source. I get some stuff, input to my app. Then somewhere along the way, I use it. So I make a system call. I send it in a parameter to a database, parameterized query, I search for it, I do something with it. So that's where I sync it. In between the source and the sink, so where I get it and where I use it, I have to validate that it's safe to use. And so the new ones and the old ones both do flow analysis. And it finds a few things, but cross-site scripting is one of the #1 things that finds. And so it'll say like, hey, you didn't validate this and you used it. This is obviously a bad idea. So that happens, and that's very fast. Then the magic. So anti-pattern matching. So a pattern is a thing you want to find. An anti-pattern is a thing you wish you would not find. It's a bad pattern. And so a bad pattern could be like using the eval function, because we know it's insecure, we're not supposed to use it. Maybe there's a hashing algorithm where that hashing algorithm is broken and it's no longer approved. Maybe like whatever the thing is. So it's a pattern, and we know every time we see it, every single time, that that's bad. 100% of the time it's bad. And so you can do searches for patterns using regular expressions. Semgrep doesn't use with regular expressions. It uses, there's another word for it. I can't remember what it is at the moment, but it uses that instead. But basically it uses its engine, and it's very, very, very fast. We're talking like seconds. So if you made a rule for something, you could search your entire code base in probably under a minute for this one rule. It's that fast. So that's one of the things with next gen, is it's very fast. It's mostly true positives. So if you have had this rule made by an expert, chances are if it finds something, it's definitely bad. Semgrep has a free version. We call it the OSS version. Those rules, a lot of them are made by the community members. And so some of them have false positives. The Pro engine is made by like our security research team, and it's tested very thoroughly, and it has extremely low false positives. So if you're using the free version, just be aware that there's some false positives. It's not like first gen, it's not like that, but there's still some. And so you should be aware that that is a thing that could happen. But the one thing about next gen SAST is that there's some false negatives. So sometimes it misses stuff. If you don't have a rule for it, it might miss it. Now, first gen sometimes misses things, but it's pretty, I'd like to see numbers on that actually. But basically, next generation has some false negatives. So it misses some things. I haven't seen it like ours miss a lot of things yet, but I'm new. But so basically you have to decide, like, do I want to be completely perfect and spend like $40,000 reviewing one app one time? Or if I want to review something in 3 minutes and I can like review all the other apps too, and I don't need to spend weeks reviewing the results and like most of the things I'm going to find I need to fix, but I might miss something. So the difference between, do I need to be absolutely perfect and invest lots of money and lots of time, or can I just be really good? And a lot of us just want to be really good. Our CEO is famous for saying, we want to make it ourselves too annoying and too expensive to hack. And it's true. Next generation SAST, they're all really new. They're mostly like 3-4 years old. So all of them work with a CI/CD, all of them work with your code repository, all of them are meant to be automatable and DevSecOpsy on purpose. And so that's important. So they're made for dev processes rather than being made for AppSec processes. Yeah, it works well with DevOps and Agile, works with their processes, and all of that's intentional. That's quite important. Yes. Okay, so why Semgrep code? One sec. So the Semgrep SAST tool is called Semgrep Code. They have 2 other products, and I'll get into them in a minute. So Semgrep Code is a next generation stack analysis tool. So it's the really fast one. I feel like I say things right before it goes on the screen, and I should say it after. It can run, it's compatible with all the CI/CDs that are popular. It's designed to show the results to the developers. It's written like it's made for using with the devs, not for a security professional to spend a few weeks on his own and then he makes a report or she and then they show it to the dev team after they've spent forever throwing out most of the results. The things that you want to fix, the true positive rate's very high. It's very easy to customize for all the dev tools. They did it that way on purpose. There's high accuracy rating, so it's mostly true positives. The pro version of Semgrep code, it can track a vulnerability across multiple files. The free version doesn't do that, and a bunch of the other next gens don't do that. So that's something that's special about Semgrep, where if you have, so sometimes you get the input in the JavaScript and you don't validate it there because it's not on the servers, it's not a trusted system. So you're like, oh, I'm going to validate it on the back end. Well, that goes down into your C#, let's say, or wherever you have on your back end. And then you're going to validate it there. Well, if it can only see in one file, it looks in the JavaScript and it's like, you didn't validate this. And it's like, yes, I did, you silly SAST. Whereas this one can track across like 2, 3, 4 files. If it goes from here to here to here to here, and then it's sunk, it's like, I saw you didn't validate it across there. I see the problem. And so it can find more bugs. And the flow analysis bugs are usually the scary ones. You can write your own guardrails really easily. So it comes with its own little editor where you can make custom rules. And so the custom rules, we'll talk about why those are like pretty handy. Yeah, they're really, really valuable. Oh, also I work there. And so I chose to work there on purpose because I like them and I like the product. So I think it's quite good. So let's talk about some static analysis strategies. Yes, I have this cat in a lot of my presentations. I just really like this cat. Okay, so we're going to go over 3 strategies. So I'm just going to read them off to you. This image is from the Sura Indigenous peoples images. So I live in Canada. We have lots of like Indigenous Canadians, and we don't usually have them in our media. So I'm trying to like have all sorts of people in my presentations. And so I think it's very cool that Sura shared lots of images for free of like people being awesome with technology. Okay, so strategies that work: selecting a tool, company specific checks, and then how to roll out. So we're going to talk about each one of these. So first one, choosing the right SAST for you. So I realize I work at Semgrep, and then obviously you should all buy it. However, sometimes you're in a situation where that doesn't make sense. So the first thing I try to figure out is, do I want a 1st-gen SAST or a 2nd-gen SAST? So if you are, if you're doing, let's say, counterterrorism activities, or if your system goes down for a minute, it's going to cost $1 million or more. Or if your system goes down, someone's going to die. Like your budget is like $1 million to secure this app, a 1st-generation SAST tool might be a great choice because it will find every single thing and you have the time to dedicate to go through every single result and be extremely thorough. When I worked at a place that will remain unnamed, but where I was doing something extremely important for the Canadian government, we got 2 different 1st-gen SAST tools. Next-gen didn't exist yet, but we got 2, and then we got 2 different code reviewers, and we did a complete code review with one and fixed all of those bugs. Then we had a second person come in and do a complete second code review. We also did 2 penetration tests, and then we did a big simulation of the thing we were working on, and then we threw hackers at it and security incidents, and then did a big postmortem. We cleaned all of that up as well, and then we did our big thing, and everything was great. But we had $1 million to secure that one app because what we were doing was that important. So then I would pick a 1st-gen. But if I'm doing DevOps and creating, like I'm trying to move fast and break things, if I need to support 100 apps with my team, if I do my work in sprints, if I like, if I need to get bug fixes out in a week, not a year, I want to use a 2nd-gen SAST tool. If it's okay to just be really, really good and not perfect, I choose a 2nd-gen SAST tool. They're also way cheaper. That's another secret. They cost like way less than 1st-gen. Does it support the programming languages that my companies use? So if it does not, like if you use 20 languages and like the SAST tool you're looking at only supports half of them, that means you're going to need 2 SAST tools. That means 2 bills. That means 2 tools to support. And that sucks. So if it doesn't support the programming languages that your company uses, you probably don't want that one. It also needs to support your framework. So if you're doing Java, but you're doing struts versus Spring Boot, does it support struts? Or if you're doing Spring Boot too, because you can't make up your mind, it needs to support both of those. That's really important. Tools can be better or worse in different languages and frameworks. So I usually ask around to friends and see what they think of the tool. And then I run what's called a proof of concept, where I install it and I use it with my real apps and test them out and see how it does and play with them a lot. Like that's what I'm like. If you have a custom in-house framework that you've written, no SAST is going to do really well with that. So you should be ready for that. Like you could write your own custom in-house rules for it, but like using your own programming framework is a lot. It's going to be hard to find a tool to help you. Does it work with your CI/CD? Does it work with your IDE? Does it work with your code repository? If it doesn't hook into all your dev tools, then it's probably not a winner. Am I going to have to manage a server that runs this tool? So previously, I've worked at places where we could not share our source code because there were laws. So we weren't allowed to ship our source code off. But I worked at other places where like we shipped our source code off to Israel to have them review it at the SAST company that we were doing. So it really depends on where you're at. I prefer to not have to run my own server if I'd rather spend my work doing AppSec work than support and operations. Will I have to share access to my source code? So Semgrep does not take a copy of your source code. So it runs the engine and sends you the bugs. We just have metadata, like how many scans you ran and stuff like that. We don't see your source code, which I know sounds weird. So some places you're not allowed sharing your source code. So that's an important distinction. Some places you totally can. Pricing, if you don't have enough money for it, then it's not going to work, right? Is it easy to extend and customize and use within my environment? And then lastly, do you need custom rules or not? So if you work on an AppSec team so quite often the AppSec team's one person. I want to make Semgrep shirts that say, I am the AppSec team. So many places I've worked, I'm like, the AppSec team's here. They're like, where are they? I'm like, I'm here because I'm the whole team. So if your AppSec team has never written code before and can't read code at all, you might not be ready to like write custom rules. But if you've ever seen code before or fixed a bug or anything like that, writing a rule is really easy. Like I remember the first time I used Semgrep was with Clint in 2020, and he came on my show. So I used to have this open source project called the OWASP DevSlop project. And he came on and did a workshop with us. And like within like a few minutes, I was like, go away, Clint, I'm writing rules. I found it really easy. And so I think like if your team has any technical experience, they're probably going to want this functionality, and most of them have it. So you can use it, for instance, to, I guess on the next slide, we'll talk about that. Okay, so company-specific checks are often the most valuable. So a company-specific check means you making a custom rule to look for a thing that you are worried about. So common trends that we see across a number of companies. So I mean like the Semgrep product team for code. So out of the box generics tests at first are awesome. So you go into an org and you scan everything, you look like a superhero. You find all these bugs and you spend a few months like fixing everything, right? So once you've fixed all of those ones that you want to fix, everything that you think is important, everything where the context makes sense to fix it, the rest you're like, I'm going to accept those risks. What do you do then? Because although we continue to release new rules, you're not always going to have those bugs, right? But there are still bugs in your code. Like there's things that are specific for your org that are important. And so you can make your own rules. So it could be, for instance, like let's say I worked somewhere And I'd made a memory leak in my code because I was using the open and close database commands, and I was doing recursion, and I forgot to close one, and I crashed prod, and I was not popular all week. And so from then on, we wanted to use something called using in .NET. And if you don't close the using function, it won't compile. And so as a result, it's impossible to have a memory leak if you're using the function called using. And so what we could do is just make a custom rule that looks for the open or close database commands. And if we see it, we're like, actually, you're supposed to use that thing called using from now on. And then we can say, no, you can't check this code in. This is what you're supposed to be doing instead. And so that was a code quality thing that we did to ensure we would never have any more memory leaks. So you could do that. So it's not just for security bugs. It could be any type of bug or like a style, whatever it is that you want, you can enforce it with these custom rules. And so you can tailor it to like your business context or specific risks. So for instance, like looking for personal healthcare information or business logic issues, which is like often design, like the way you built a thing. So you can test according to your threat models as well. So if you're doing threat modeling at your org, then like you can actually write rules to look for those threat models. So business logic bugs generally, static analysis and dynamic, like none of these tools can find business logic flaws out of the box. This is a thing that it takes a human brain, and then you write these rules. This is why pen testers get paid so much, because they have that evil mindset and they know to look for those types of flaws. So you can teach your tool to look for those flaws. And so then this quote's from a customer where basically they had a submission to their bug bounty program and it was really scary. And then they wrote a rule to look for that code. And then they found it again somewhere else within an hour and fixed it. So then they fixed 2 bugs for the price of 1. And so your devs made many of your apps, not just one app. They wrote lots of code. They might have made that mistake more than one time. You can go find all of them within a few minutes. And that's nifty. So rollout of stack analysis manual. So these are ways to roll it out. So sometimes people roll things out manually, and that is allowed, and that is okay. If you don't work somewhere where there's a CI/CD, you don't want to hook it up to your code repository, or maybe you're not allowed. I've worked at places where I did not have read access to everything. So, and I had to earn that trust. So sometimes you want to do things manually. So you could do a full scan of every code repository. So you could add them one at a time. You could download a copy and scan those files. I try to choose the most important ones to start. So the mission critical types of apps, I start with those. So then you can make a game plan. So you could do developer education. So you show all of them how to use this tool. You show them what the results mean, and then you're like, this is where you find answers on how to fix things. Then you create coding guidelines so that they don't keep making these same mistakes, and you teach them these coding guidelines. Then once you come up with a list of like, this is what's not allowed here, you make custom rules to block those things. So you can make it when someone checks in their code, you can do a pre-commit hook and say, I'm sorry, that breaks this rule. No. And it doesn't let them check in their code, and it makes them correct it. And so this is a thing you could do. You could also look for specific bugs. So when I consult places, so I work at Semgrep full time now, but before that I was doing a lot of consulting, and I'm still doing a little. I would go in and I would like immediately try to find the top 3 problems I see all over the place. And then I would chip away at those problems so I could show a return on investment to my boss and get my contracts renewed. It is a great way, like solving a class of bugs, to get buy-in from developers and upper management. Okay, so let's say you do have access to the CI/CD and you want to roll it out that way. So you could roll out just really important checks first. So you could just check 5 things. So it takes like a split second to run. And it's things that you're worried about. So let's say your top 3, and then you look for injection and you look for cross-site scripting, and that's it. And you just want to check those 5 things. And you could just start with that for the first few months, get everyone to fix those things. And then, oh yeah, and partner with a nice team to start, practice on them, and then move on to more teams. I like to start with just notifying the security team at first of the bugs. Then eventually you can make like a pull request on it saying, hey, I found this bug. And then eventually you can say, sorry, you're not allowed running the CI/CD. Like, I'm breaking this build. This is not allowed. Like, we've told you like all these times about this. Do not pass go. Do not collect $200. Just go straight to dev jail. Just kidding. You can turn your penetration test results and your bug bounty results into custom rules and add those to your CI/CD. You can also, like, when you make a custom rule, you can do kind of like a rainbow rule where it's like a rainbow table or a rainbow stretch, a rainbow credential stuffing attack. Like, it's where you like do variations on the thing to find every single thing that's even sort of like that bug. And that's really helpful, and add it to the CI. And basically you can raise your security posture just like a little bit at a time. So it's not like I'm reporting 67 bugs to you one day. And that's a good strategy. Developer tools, I can take any put you can think of. I can do anything. Security tools, I need to be built on this really old operating system. Also, could you please disable the firewall? Thanks. I have worked with so many security tools that are not very security focused. And I'm just like, this meme's very funny. This meme's from my friend Clint. Okay, so now we've looked at SAST. So let's look at supply chain security. Actually, are there any questions? Because I'm not seeing any questions in the chat. I just want to make sure everyone's still doing okay. I'm seeing you're all still here, so that is a really good sign. Thank you. I appreciate you. I'm going to take a sip and give you a moment to type in case you do have a question. Oh, thank you. Thank you. Okay, awesome. So there's no questions. Let's go. Okay, so supply chain security. So what's that? Oh, just a second. There we go. So your supply chain is every single thing that you need and you use to create a product. So let's say you're creating soup. So all the ingredients for your soup. So obviously there'll be garlic, right? And then you have some broth. You probably have some herbs and spices. Then you probably have some sort of main thing. So let's say you're making butternut squash soup. So you'd have butternut squash. And then I like to put rosemary in it and carrots. So all those ingredients, that's one thing. Pots and pans, you got to cook it. You need a stove. You're going to need to heat that stove. You're going to need some electricity. You're going to need a safe place to do it in. You're going to need a kitchen. You're going to need to sterilize everything. So you're going to need cleaning stuff. Then you take that soup, you put it in a can. You put a label on the can. You put ink on that label to say what it is. There's glue to hold that label to the can. Every single one of those things is part of your supply chain, and you would need to keep every single part of it safe. Oh, there's a question in the chat. You said that SAST doesn't require a security expert. I think that we need them so that we can analyze the findings and confirm whether they are false positives or not. What do you think? So, Tuzi, you have a really good point. So you can run a SAST without a security expert. Then you get the results. A developer can look at most of them and figure out if it's a real bug or not. Usually developers are capable of doing that if there's just one or two. If you're going to hand them a thing with 10,000 pages, I've seen this. I have seen this with first generation SAST, like reports that are literally 10,000 pages. You can't hand that to a dev, but you can hand, here's 6 things to a dev, and they would have time to look at that. And so what they do is they go to the part of the code where it says the bug is, and it's like, is it doing what it says it does? Is that problem actually happening? And like, if it says this function's bad and you're using the function, then you see the function, like it's pretty obvious that you are. Sometimes it's like, we think this has cross-site scripting, and you look at it and you're like, I'm not sure if this is exploitable, but the pattern looks like cross-site scripting looks, right? And it means you're missing mitigations, defenses, and you should add those defenses if they're missing. Sometimes you have the defenses and it's like, these defenses are not created correctly. This is how it would be correct. Then you want to correct them. Sometimes there are false positives, but I guess I think that they can do it when you just have a small number of results and the results are mostly true positives. But you're right. Sometimes you have to ask the AppSec team. Sometimes I'm like, I'm just lost. I don't know what this is. Like when I was a dev. So sometimes you do need help. But as opposed to having to have a security expert press the scan button and actually review all the code. You don't need that if you have a SAST. So I feel like we sort of agree, hopefully. And did I answer your question? And also, this is just my opinion as well. We'll see if there's a response. Okay, so more. So what is supply chain security? So the software supply chain is all those libraries and third-party code. So that can be a component, a NuGet package, a Ruby gem, a library, a DLL, whatever it is, all of those that go up into your app, code that you didn't write, that's part of your supply chain. And those need to be safe. The CI/CD that you use, all the settings, all the tools, all the setup, all the scripts, all of that, that is part of your supply chain because you need it to deploy your code. Your IDE plus all the plugins and any sort of setup and configuration and environments you've done, like all that time you took, that is something to be protected because that is effortful. Your code repository. So like your code is so valuable. Twice I have worked at a place where they lost all the code and I wanted to pull all my hair out. So once they lost it before I arrived and I was able to recover some of it. Another time it was after I was there. I was so angry. I was very, very angry about it. I did not lose it. I had warned them. Anyway, I won't go on and on about it. So your code repository is very, very valuable. And that's part of your supply chain. Any single tool that you use, any like sandbox you have set up, anything that you need to create your software, that is part of your supply chain, and every single part needs to be protected. And so malicious actors right now, they're targeting these systems because they know we need them and how valuable they are. It's important we use safe components to build our apps. So whenever possible, like not choosing a framework that's known to have lots of problems or avoiding libraries that we know have lots of bugs in them. Or if we're going to use one of those, making sure we're not calling any of the parts that have the vulnerabilities in them. So we're using them safely. And we need tools that are reliable and trustworthy. And so, yeah. So why Semgrep supply chain? So what Semgrep supply chain does so far, so they're expanding on the tool, they're adding more functionality all the time, but I'm not allowed telling you what's coming. It finds libraries that are in your app and third-party components, third-party code that have vulnerabilities in them. And it tells you, hey, these ones have vulnerabilities. It tells you if that vulnerability in the library, so a library has like thousands of functions, maybe just hundreds. Functions, which are parts of the code that you call and you ask it to do something. So there might be one called average, and you put some numbers in it and it gives you back the average of those numbers. So that would be a function. If the vulnerability in the library is in the average function, if you don't call the average function, you're probably okay. You're probably not exploitable. It's probably not dangerous. But if you are calling that function, you're probably not okay. It's probably bad. And so it tells you, are you calling that part with the problem? And we call that reachability. It works with all the popular tools because it's new. And so all the new ones work with the cool, with all of the cool dev tools. We have a giant security research team that researches all of these for us, and they work really hard on it. The results are very, very fast. So spoiler alert, all the SCA tools are fast. I haven't seen one that's really slow, but it's quite fast considering the level of analysis it's doing, like to find that reachability. Oh, and then one more time. So reachability means you have these 12 libraries. These 2 libraries of the 12 libraries, you're actually calling the function inside the library that has the vulnerability in it. So we're really worried about these 2, but the rest, you're not calling that part. So there's a good chance that you're okay. And maybe that's going to be a lower priority risk for you. Like maybe you'll throw those in the backlog for eventually being upgraded off of. But for now, it's like, I'm not too worried. So you can avoid having to fight. Also, did I mention I work there? That is also a big plus as to why we want Semgrep supply chain. Okay, so reachability. Oh, is that even a word? Yes, it is. I already told you this. So basically, if the vulnerability is reachable, you're probably going to have a problem. It's probably bad. If the vulnerability is not reachable, you're probably okay, but it's not guaranteed. So an example of this where this was not true was log4j. So if you called log4j, you were in hot water, period. Everyone was in hot water. It did not matter. But for most of the time, if you don't call that function, you're not exploitable and you're safe. So if you know which ones are probably exploitable or not exploitable, you don't have to spend your social currency asking to get things fixed. So Semgrep released a statement saying it was 98% fewer findings. So like 98% were unreachable. Some customers are saying it's more like 95%, but imagine you have 20 bugs and you only have to ask to have one fixed instead of all 20. How much easier is that conversation going to be? Way easier. That's what. And so I'm pretty excited about this. The printer that simply worked and other fairy tales. Yeah. Okay, so now we're going to talk about secrets. Okay, so what is the secret? A secret is what computers use so they can recognize each other. So they're like, hey, I'm this app. And it's like, I'm that API. Should I talk to you? Yes, here's my identification. You can talk to me. Please give me that data I asked for. Okay. Computers can't look at faces and tell who each other are. They need to use something to recognize each other, and secrets are what they use. So it's like authentication, but for machine to machine. So an API key, a secret, a hash, a certificate, a password, a connection string, all of those are secrets. So it's something we want to keep a secret. We want to keep it confidential, and they share it with each other to show each other. Oh, there is a question from Jennifer in the chat. For reachability and supply chain, does Semgrep generate a software bill of materials? Yes, but you have to click an IDE. There's an IDE plugin for it. So you have to click some extra buttons to get it to do the software bill of materials for you. So it does do it, but there's some extra buttons to click. I believe they're going to build it into the main product. I don't know when though, like probably sometime this year, but right now you have to click some extra buttons. So if you want to do that, you just tell the support team and they show you what to do. Like they have articles on how to do it, but it's not out of the box that way just yet, unfortunately, but they're working on it. So someone made that this summer and then they're just operationalizing it. So yes, good question. Okay. So secrets are not supposed to be stored in our code, because then they can be used in unintended ways. So an example, I don't do pen testing anymore. It's so not my job. I'm really rusty, but I did one in 2021 for an old client. And I did some code review and I found all their live banking information. So I could have gone and robbed them. I am not a bad person. So I did not do that. What I did was I called the company that made this app and told them, I found this. I need you to change this right now. Go change your passwords. And then we'll fix the code so it works in the morning. And so them changing their passwords called rotating their secret. If I'd been an evil person, I would have just emptied their bank account and gone on vacation, right? But luckily, I'm not bad. But that could have been really scary. And then I told my client, so my client was going to buy that company. I told them after, and they're like, you should have told us first. I'm like, no, I have to tell the person who the secret belongs to. So these secrets should not be in your code because they can be used for badness, like stealing, theft, seeing data they shouldn't see, ruining data, harming systems, terrible stuff. So your secrets should be stored in a secret management tool. So Semgrep does not make a secret management tool yet. I want us to make one of everything, but I'm not the boss of product. But some examples would be HashiCorp Vault, CyberArk, Azure Key Vault. All the cloud vendors make secret management tools. There's one for Kubernetes. There's just like a whole bunch of secret management tools. And they programmatically handle all of this. And some of them can even rotate your secrets for you every so often. So they just do like once you set it up, they just handle it. and you don't have to remember anything. You don't ever have to see these secrets. What Semgrep does is it scans and finds your secrets in the code and helps you know, I need to go rotate this and what you should be doing instead. And so scanning for secrets can avoid security incidents. So secrets rollout. So if you are going to start scanning for secrets, I like to scan the entire code repository. If you have an intern or a co-op student or a junior person, this is a great task for them because it's very high value. If they find a single secret, they just helped you so much. And it's boring. So at first it's like exciting. And then after a day or two, you're like, so it scans the entire code repository. You find all of them, suppress false positives. So an example of a false positive, oh, there's another question that's really good. I'm going to answer that in a minute. So if you find a false positive, you want to suppress it in the tool. So an example, I worked somewhere and we had a license key, and that's a secret. But that company had gone out of business. And so anyone was allowed to use this license key because they weren't in business anymore, and therefore we weren't violating any license agreements. And so as a result, it was like all over the place, but we're like, who cares? Because anyone's allowed to use this thing. So you still needed the secret, but it didn't need to be a secret. It didn't matter if it was spilled. Okay, so answer our question in the chat. Any idea about software composition analysis and SBOM? So the Semgrep supply chain tool is a software composition analysis tool, but I believe that they intend to add more functionality to protect more of your supply chain. And thus they didn't want to name it SCA because it's going to do more than just that. So any advice to remediate to libraries with known vulnerabilities, especially if we don't have enough budget for upgrading and fixing capabilities? Yes. So if you have a library where you believe it to be exploitable and it's a really big bug that scares you, you have some options. So obviously, like upgrading off of it is not using that library anymore is the number one thing to do. But sometimes it's going to be really expensive. So in the past, some of what I've done is buying a web app firewall and then getting a look at what attacks for that vulnerability look like. And then I made a virtual patch. So a regular expression that looks like that attack. And then I just blocked anything that looked like that. And that is not a perfect solution. And you still have to buy a WAF. It was like $5,000 for the WAF license. But for me, that was good enough. And so we deployed that. We only had 4 customers and we deployed it on the 4 customer sites. And so we blocked like obvious attacks and then that attack. And that took like a few weeks, but it was that or a complete rewrite. And that was way cheaper for us. So that's what we did. Another thing you can do is do network segmentation around that app. So if someone does get onto it, they can't get out anywhere else. That's another thing you could do. So I hope that answered that question. Regarding secrets, if we use a secret management tool, does it mean we should connect to it from our applications? Yes. Should we then use tokens, which are considered a secret? Therefore, can provide as additional details about the standard workflows to be implemented. Is there something standard? So if you buy a secret management tool, they will guide you on best practices. I have a blog article and a conference talk about this, but I'm seeing we only have 5 minutes left. So the secret management tool will programmatically connect to your CI/CD and get the secrets. It will connect to your IDE. You can write it so your app like calls the secret management tool and gets the secret and unlocks the thing with it. So you never actually need to handle the secret. And they give you instructions on how to do it with each secret management tool. I used to have a video of me doing this for Azure Key Vault, but it's been lost a long time ago. It was really long. It was like 2 hours. Me and my friend Abel made it. And it took forever because it was the first time I'd ever done it. But 2 hours to set it up once. And then from then on, like 10 minutes for each additional app. And so it wasn't that hard then. And then it just handled everything for me from then on, which was awesome. So when you buy a secret management tool, they will help make sure you implement it correctly. Great questions. Okay, So when you find a secret, you have to rotate it. You have to get it and you have to reset that password, generate a new hash, whatever the thing is, you have to generate a new one. You do not take the spilled secret and check it into the secret management tool, because that secret is all through your history and your code repository. It's probably saved locally to people's laptops. It is spilt, you must rotate it. Once you've got all the secrets, you've rotated them, you've checked them all into the secret management tool, you're accessing them programmatically, then I like to add a pre-commit hook. So as you check your code into the code repository, how do I word this? It checks for secrets on that bit of code you changed. And if you did one, it stops you. When I was at Microsoft, I made an intentionally vulnerable demo and I put a secret in it on purpose, like a fake one to a fake thing. And how do I word this nicely? So Azure Cred Scan was like, no. And I was like, yes. And it was like, no. And I was like, yes. And I forced it because I was a dev. So I just did whatever I wanted. And I just pushed it into the code repository anyway, and like disabled all the stuff and was like, screw that, I'm doing it because it's a demo. Azure called my boss. So I get this call from my boss and he's like, Azure just phoned me and told me that you put a secret into Microsoft's code. What are you doing? And I'm like, oh no, Azure is angry. I'm like, I made this demo and I was telling him, and then we both laughed because we're like, haha, Azure's angry at Tanya. Haha, you tricked Azure. And then we were laughing about it. And I'm like, oh, I have a beep. I have to go. I have a call coming through. Well, that call was the Microsoft Incident Response team. And they didn't think it was funny at all. And it took like a year before they liked me. And like, they were like, please don't trigger security incidents at Microsoft. We have real work to do. I'm like, I'm so sorry, ma'am. And so you don't want to be that guy. Yeah, don't be that person. Yeah, so you can relax by the pool now because you're cool. And so you've blocked all secrets from then on. So then you don't have to worry about this anymore. So why Semgrep secrets? So it does validation. So it tells you if the secret is live or not. And it uses semantic rules. So semantic rules, so basically we use our big fancy engines. Our engine's really cool. And it uses more than just regex and entropy, which is what all the free ones use. So it has a much higher accuracy rating of this is a secret versus it's actually just something random. And then we check to see if it's live or not. So you know, I need to panic and go fix it right now, or I should change this eventually. It has higher accuracy. Also, did I mention I work there? Because I do. So in the supply chain, so you can do software composition analysis, supply chain security secrets, and SAST at various stages in the system development lifecycle. So you can scan all of these while you're coding. So you can scan it in your IDE. And you can scan it every time you check in your code as well, if you don't want to do it in your IDE. Then you can test every single time you do a release. So if you're doing a CI/CD, you can test it then. You can test it during the testing phase. And then you can have weekly scans against your entire code repository. It's really easy for you to continue these scans and making sure that things are safe because we release new rules. Maybe you release new rules that you wrote. So daily or weekly full scans. If there's a CVE, a common vulnerability enumerator that comes out, like you can go and look for it immediately. So when it comes to costs, the earlier that we fix a bug in the system development lifecycle, the cheaper it is. And so it costs a little bit if we check it while we're coding, but it costs more if we check it while we're testing. Like if I just wrote that line of code, it's fresh in my mind, it's right there. I don't even need to open it and find that file. But if I'm doing it during the testing phase, I have to be like, what was I working on? What file was that? I have to open it up. Then after we've deployed it, that's way more work. So it costs way, way, way more. But if it's after it's in production and a malicious actor finds it, it costs a lot and a lot and a lot of money. And so ideally, we want to find these bugs and fix them as soon as we can. And with that, I'm going to do a quick demo. Is everyone able to see my screen? I'm hoping that you're able to see my screen. So if someone could just put like, yes, you can see my Semgrep dashboard. Because I think that if I just switch it, you should be able to see this one instead. Yes. Okay. Thank you so much. Okay. So I scanned a whole bunch of, I just like this morning well, some of them this morning, some of them last night. I just grabbed a bunch of vulnerable things off of GitHub because GitHub has some projects that aren't doing so great. But these are intentionally vulnerable apps. And then I scanned them. And I just had to like click a couple buttons and then it scanned them. And then I went to my meeting. And so I found 16 secrets. 16. And like, that's pretty cool. So I found some in the OWASP broken web apps. I found some in my crappy .NET Core web app that I built. I found some in Matilde. And so like I found private keys, connection strings. So like this is great because then I could go and fix these in my code. I also found all sorts of SAST. So this is our SAST. I found a lot of bugs with that. And so then I would go through one at a time and check these. And then in the supply chain, I found 14 vulnerabilities that are reachable. So then there's 100 that are not reachable. So I could probably skip those. And then 85 that are undetermined. So I'd probably want to look through the undetermined one and see what I think. But basically, to add a project, I just went scan a new project. Where do I want to scan it in the CI/CD? Oh, I'd have to actually, wait, let me go back here. Projects. So these are all the projects I'm not scanning. And so I just like pick one. So let's say I'm going to do this one and I add a CI job. I've already read this. So I just click yes. Oh, wait a minute. Oh, no, I remember I deleted my secret. Just a second. That's a bad example. So let's do this one instead. Actually, let's do this one instead. Oh, actually, let's do this one. So, and I click commit file and then it commits the file and it just starts scanning it for me. And then in a few minutes, so it's starting, in a few minutes, it'll just tell me my results. It's really not a lot of work to like set up all the things and just scan them. If you haven't deleted your secrets this morning because you're fooling around. So it was like my secret in GitHub that I deleted. Anyway, I trash things a lot on GitHub. But so it's really, it's not hard to run. And then you just go through the results a bit at a time. And so that is just like a very, 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 very brief demo because I'm totally over time and I'm supposed to be in a meeting. Sorry. Okay, so with that, I want to do a conclusion and give you some resources where you can learn more. And then we're going to say goodbye. So what did we learn? So we learned what SAST or stack analysis, supply chain security, and secret scanning are. The value each one can bring and when we might want to use them. And then I gave you some strategies about how to get kind of the best results when you're using them. And that Semgrep can help you with all of the above. And that's my sales pitch. Semgrep can help. And with that, I want to do some resources and then a quick goodbye. And so resources. So the first resource is Semgrep. So I am starting so Semgrep has a little community with a Slack channel, and that's the second link there. And you can, how do I word this? So you can join the Semgrep Slack and hang out. We're moving to Mighty Networks, where we're going to combine the WeHackPurple community and the Semgrep community together into one big mega community. So like all like 11,000 people can hang out together, and all of you are invited. So if you want to join the newsletter, that would be the best way to keep track of that, or the Slack. And then this is if you just want to try the product. Next resource is me. So I am She Hacks Purple on every platform. I have a YouTube, I have a blog, I have a newsletter. I do lots of nerdy stuff. So if you liked this, there's more of this. I'm going to be doing a lot of stuff with Semgrep. So joining their newsletter is good too, because we announce every single Semgrep community thing on there. And then I'm going to still put lots in my newsletter. But anyway, between the two of them, you should have some pretty darn good coverage. And then with that, if you wanted to get these slides, the slides are available right away at this link. And maybe I'll exit out of, how do I do this? If I can exit out of presentation mode, I don't know how to exit out of presentation mode without screwing up. Okay, so that's it. So I don't know how to copy this link for you. Oh, actually, here we go. There. So basically you click that button and then you can get the slides. And I'm just going to put it in the chat so that you all have it if you want to get the chat, if you want to get the slides. A lot of people like getting the slides. And with that, thank you. Thank you for coming. I really appreciate you being here. We weren't sure how many people would come, but we had a bunch of people ask because I did this in San Francisco, and then my colleague Caesar did it in New York City, and people were like, oh, we really liked it. Can you do it online? And I was like, yes. So thank you so much for showing up, because you never know when you do one of these if anyone's coming. And so, oh, my pleasure. Are there any last questions before I go to my meeting I'm supposed to be at? I know I shouldn't have. Thank you. Thank you so much for coming. Awesome. I really appreciate all of you being here. The recording will be out soon, so we'll send an email with the recording in case any of you want to see it later or show it to anyone. And I hope to see you at some future Semgrep community events. So next month, I have a woman named Chloe coming, and she's going to show this cool open source DevSecOps pipeline that she did with all OWASP tools. And then another person's coming, Lee Honeywell, and she's going to talk about how to defend your digital devices and how to defend yourself against digital stalkers, which is really cool. In December, we haven't announced it yet, but this guy named Nate Case is coming, and he's going to talk about, his talk's called Down with the CISO, even though he's a CISO, and sort of the history and evolution of the CISO role and how to be a really good CISO that's good to your people. And run an amazing security program. And so that's some of the stuff we have coming up. And I hope to see some of you there, and I will see you next